Alright, so hi guys. So I hope everybody is doing well. Happy holidays. So in this video, we're gonna go ahead and solve this by substitution. Now, I will admit that this problem, it is pretty difficult. It can be very tricky, especially because there's fractions in here. There's gonna be fractions involved. So it is gonna be difficult. So it says solve the system by substitution. State the solution as an ordered triple. So we have x plus y minus z equals 6, 2x minus 3y plus 5z equals negative 1, and 7x minus 5y plus 8z equals 9. So we're gonna go ahead and look at equation 1, so we know that this is equation 1 here, or the first one. We're going to grab x plus y minus z is equal to 6, and we're going to go ahead and solve, or isolate. I'm going to do x algebraically. By isolating, I mean get it by itself. So to do that, we're going to go ahead and subtract y and add z to both sides. So then we have x equals 6 minus y plus z. Okay. And now let this be new equation 1. So we're going to basically do an arrow, and we're going to say that x equals 6 minus y plus z. So that is new equation 1. We're gonna do the same thing. So now we're gonna substitute this. So we're gonna grab this stuff, and we're gonna substitute it for equations 2 and 3 to get a system in two variables, in two unknowns. So we have the following. So 2 times the quantity, 6 minus, so it was 2x minus 3y plus 5z is equal to negative 1. And we're going to substitute this stuff. So 2 times 6 minus y plus z minus 3y plus 5z equals negative 1. So now just do distributive property and combine like terms. So here we have 12 minus 2y plus 2z minus 3y plus 5z equals negative 1. Combine like terms. So we have 12 minus 5y plus 7z equals negative 1. Subtracting 12 on both sides. Excuse me, guys. We're going to have negative 5y plus 7z equals negative 13. So here we know that for equation 2, it's going to be negative 5y plus 7z equals negative 13. So, oh, and I forgot to label here. This is what we're substituting, guys. So that is what we are doing. All right, so now we know that this is going to turn into, so we have negative 5y plus 7z equals negative 13. So let this be new equation 2. Now, so that is going to be new equation 2, guys. And now do the same thing for equation 3. So we have 7x minus 5y plus 8z equals 9. So, and now we're now going to just substitute. So 7 times the quantity, 6 minus y plus z minus 5y plus 8z equals 9. So now what you're going to do is, again, do the same thing that we did before. Distribute and combine like terms and move the constants to the right side. So we have 42 minus 7y minus plus 7z minus 5y plus 8z equals 9. So now, looking at your like terms, we have negative 7y, negative 5y. We also have, we also have a 7z and an 8z. So it's going to be 42 minus negative 7y minus 5y, that's negative 12y. 7z plus 8z, that is 15z. So equals 9. Here we're going to have the following. So it's going to be the following. So we're going to do 42. So we're going to subtract 42 on both sides. Doing so, we get the following. So 42 minus 9, that is 33. So it's going to be negative 33. So we have negative 12y plus 15z equals negative 33. Okay. Let this be new equation 3. So this is going to be new equation 3. So we're going to have negative 12y plus 15z equals negative 33. And now we have a system of two equations and two unknowns. So the new linear system is going to be the following. Negative 5y plus 7z. So we're going to do it this way. Equals negative 13. And then we also have negative 12y plus 15z is equal to negative 33. Now, what we're going to do, this is where it gets tricky, guys. We're going to go ahead and solve for either, we're going to isolate either y or z algebraically. So we're going to grab equation 1, negative 5y plus 7z equals negative 13. We're going to solve for y. So in this one, we're going to have minus 7z on both sides. We're going to have negative 5y equals negative 13 minus 7z. Dividing both sides by negative 5. Now, here's the thing. You want to try and what you're going to do is the following, guys. We're going to divide both sides by negative 5, but you want to be careful with your signs, okay? So what this is going to do, we're going to have y equals negative 13 over negative 5 minus 7z over negative 5. Both of these are going to turn positive. So we're going to have y equals 13 over 5 plus 7z over 5, which all in all equals, so y equals 13 plus 7z all over 5. So this is what we would have for new equation 1, right? In this case, this is what we would have here. So we're going to have 13 plus 7z all over 5 for y. So y equals 13 plus 7z all over 5. Now what we're going to do, we're going to substitute this in for this stuff. Actually, sorry, no. For this stuff here. So we're going to have negative 12. We have negative 12y plus 15z equals negative 33. And as I said earlier, as I said a second ago, substitute this. So we're going to do negative 12 parentheses 13 plus 7z all over 5 plus 15z equals negative 33. Now, what we're going to do here, so negative 12 times 13 is negative 156. So it's going to go negative 156. We're going to distribute negative 156 and then minus 84z plus 15z, and this is actually over 5, equals negative 33. Now, this is where after this, what we want to do is get rid of any fractions. So get rid of fractions. And how do we do that? We're going to multiply by the denominator, guys. So we're going to multiply this whole thing by 5. And then, as well as on the right side. And let me move this right quick. So here we're going to have the following. So it's going to be negative 156 minus 84z. Because in reality, the 5 and 5 are going to cancel out. Okay. And then plus 15 times 5 is 75z. And then is equal to negative 33 times 5. That is going to be negative 165, if I'm correct. Thing is, guys, I don't know if they'll let you use a calculator for this. Maybe an arithmetic one, a simple one. But here we're going to have negative 156 minus 84 plus 70, negative 84 plus 75. That is going to be, let me see here, hold on. Is it negative 9? Hold on. It's going to be, yeah, negative 9. So minus 9z is equal to negative 165. Okay. We're going to add 156 to both sides here. So now here we're going to do negative 9z is equal to negative 165 plus 156. 165 minus 156 is going to be the following. Hold on, guys. Let me see right quick. It is going to be... So it's going to be negative 9. So now we're going to go ahead and divide both sides by negative 9. Once you solve for one variable, guys, it all becomes easy from there. The thing is, and so after this, what we're going to do, we're going to grab, so you can either use this, so we're going to do it this way. We're going to do y equals, and we know that z is equal to 1, so we're going to substitute this into this, okay? So 13 plus 7 times 1 all over 5. It's going to be y equals 13 plus 7 all over 5, which is equal to 20 over 5, which is equal to 4. So y equals 4. And now finally, we're going to go ahead and go back to the beginning of the equation that we went ahead and solved for x in terms of y and z. So x equals 6 minus y plus z. So here, so then we're going to substitute y equals 4 and z equals 1. So substitute this here as well as this over here. So z equals 1. Again, let me write that down. So you're going to substitute this for z and 4 for y. So then x is going to be 6 minus 4 plus 1. X equals 2 plus 1. So x equals 3. So we know that x equals 3, y equals 4, and z equals 1. So the solution as an ordered pair, as an ordered triple, sorry, is going to be 3, 4, 1. And that is going to be the final answer, guys. I do want to say this is a very tedious topic if you're doing it by substitution. Preferably, this would be done by elimination. However, I don't know if, I think there are professors or teachers that are very cruel or evil, and they force their students to do it by substitution. But yeah, with that being said, guys, thank y'all so much for watching. If anybody has any questions, please let me know. And happy holidays to everybody. Merry Christmas, etc. And with that being said, please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.